This video, I'm going to be going over some half-life word problems. I'm going to be explaining it from the perspective of, at least from the students I've worked with recently, just modeling it with the exponential function, like half to some power. Okay, I'm not going to use the calculus method in which I'm going to use the general exponential model with E. Just to clarify, I'm going to relate the two though toward the end. So if you're interested in that for some reason, uh, fast forward toward more toward the end. If I remember, I'll put a timestamp as well. Okay, but this is how I'm, or for those students that are struggling with these problems and they're not in calculus, they're probably just using half to some power. And I'm going to explain how to use the formula if you want to memorize the formula, or how to think through and reason through the problems without memorizing the formula, which is the method I actually recommend. Okay, so let's begin. So here's the general formula. I'll just explain it first. Y equals y0 times half to the t over h, where y is the final value or the final amount of the substance. Y0 is the initial amount. Half, it's just the, because half-life is halving, so this is why it's half here. To the t is the amount of time that passed. H is the half-life. Okay, so at least for me, I like to understand why this formula came about, or how this formula came about. And that comes from deriving it and all that. It's, at least for me, it's harder to memorize it without understanding it. Okay, so I'm going to explain the pieces of this, and that's why I said in this last point here, I would not recommend memorizing this, because if you're able to understand how this formula came about, then you don't have to memorize it. You can actually just piece it together on the spot, on the fly. Okay. And there's also just way too many formulas to memorize. You usually learning this in, you're probably learning about exponential functions, properties of exponents and all that. Maybe you're also learning this in the logarithmic section, log section. You're learning about the properties of logs, logarithmic functions, how they look and all that. There's just way too many things to memorize. There's a lot of properties of exponents and logs that you have to memorize. So this is just another thing you have to memorize, which can be overwhelming for some students. So for the students that are able to reason through, I would not recommend memorizing this. Okay, and I'll show you how I think of it without think of the problems without memorizing this. Okay, all right. Let's begin with an example. Problem number one. This substance, I took this from some other website, from another YouTuber, tutor. I just took the exact same problems. Fermium-253 has a half-life of 3 days. If we start with 1,200 milligrams, how much, fermium-253 will be left after 10 days, okay? So if you are here just reviewing for a test, maybe try this problem first yourself, pause the video, try it yourself, and then come back to see the solution. But if you're totally lost, this is how I think through it. So without using the formula first, okay, we're going to kind of derive a model. We have to understand what half-life is, first of all. Half-life is just after, or in this particular scenario, after 3 days, the amount will half. So what's half of 1,200? That's 600. So let's kind of like write a table of the first two columns first, okay? So after 0 days, so no time elapsed, you started with, or you have 1,200 milligrams, okay? After 3 days, the amount halves. So after 3 days, you have half of 1,200, which is 600, okay? And after another 3 days, so 3 plus 3 is 6, it halves again. So you take the amount that was there at 3 days, you have it again. So 600 times half is 300. And then just for getting the point, hammering the point home, another 3 days passes, so it halves again. So what's half of 300? 150. So hopefully from here, we can kind of get the pattern, okay? So we started with 1,200, we halved, and we keep halving every 3 days. That's where it's the exponential model. It's half to some power, okay? Because we keep halving, we keep multiplying by half. So it's half to some power. So this is what this third column comes in now. So let's ignore the first row first, okay? So to get from 1,200 to 600, what did we do? We did 1,200 times half, or half to the first power. Now, to get from 600 to 300, we halved again, or we do it with respect to the initial amount, 1200. We halved, and then we halved again, or we a quartered, basically. Or we write it as 1200 times half squared, because we halved twice. We multiplied by half 2 times, which is squaring. And to get to not after 9 days, we halved 3 times. So half times half times half from the initial amount, 1200, which is 1200 times half cubed. Okay, this is how we think through it. And then to get this one, remember I said, let's skip it. Let's go back to this one. This is essentially half to the 0 power. What's something to the 0 power? That's 1 when the inside's not 0. Okay. So this is our model. You can think of it like this. So what's the question asking? How much left after 10 days? So it's going to be for sure less than 150 because 9 days is 150. So when we go one more day, it's going to decay a little more. So how many halvings occurred after 10 days? So let's think of it again. After 3 days, 1 halving occurred, half power to the first, or half to the first power, sorry. 6 days, 2 halvings occurred, so half squared. 9 days, 3 halvings occurred, half cubed. So 10 days, how many halvings happen? It is 10 over 3. If you think about the math, this is 9 over 3, which is 3 right there. 6 over 3, which is 2 right there. 3 over 3, which is 1 right there. 0 over 3, which is 0 right there. So this is how we think of it. Okay, so after 10 days, 10 over 3 halvings occur. So not another full halving, for sure not, because it needs to be 12 days for it to halve again. We're only at 10 days. So that's why it's a fractional number, or a decimal number. It's 10 over 3, not a nice integer number, okay? So the amount left is 1200 times half to the 10 over 3, which this, if you put in a calculator, it's about 119.055. Don't forget your units though, milligrams. Okay, so this is how we think through it without memorizing the formula. This is how I recommend, at least, to think through it. Okay. Of course, if you have the formula memorized, it's a little quicker. Let's go through that. So this is the general formula. What's the information they gave us? Half-life is 3 days, so H is 3. We start with 1200 milligrams, so Y0 is 1200. 10 days, so T is 10. We plug in the pieces. So 1200 times half to the 3 over 10. Actually, not 3 over 10, sorry, it should be 10 over 3. Then now it's the exact same as before, right? 10 over 3, 10 over 3 is right here. Okay, so if you just memorize the formula without understanding that 10 over 3 is the amount of halvings that occurred, it's kind of hard to memorize this formula. And if you totally forget this at test time, let's be honest. After this test that you have, you're probably going to forget this formula. So if you're given this on a pop quiz for some reason, like a month from now, you probably don't remember this formula. So this is how we think through it in this slide. We slowly go through it. It takes longer, but we are able to reason through it to get the answer without memorizing the formula. Okay. Okay, let's go through number 2. This asks a little differently. So the half-life of this guy, I'm not even going to bother pronouncing it. I'll try, I guess. Americium, let's say, is 7370 years. How long will it take a mass of americium-243 to decay to 73% of its original size? Okay, so I'll be honest, even if we memorize the formula, some students will panic. We're not given a Y0, nor are we given a Y, actual amount. So they start panicking and they don't know what to do. So this is where we need to be able to reason through these problems, to think through these problems. Okay? Because they can ask it a little differently. And if you've never seen it before, then you don't have a procedure to follow. Okay? This is a lot of pain that a lot of my students in my real life have, because they try to just follow a procedure every time. But once the problem changes a little bit, or I tweak the problem a little bit, they get totally stumped. Okay, so let's, without the formula again, let's derive the model kind of, okay? So as I was saying, the problem doesn't give an initial mass, so are we stuck? No, we can either symbolically solve it, which I do in future slides, not here, or we can just give an arbitrary initial amount. So let's keep things simple. For example, let's suppose that we start with 100 grams of this guy, this americium or whatever it was, okay? So if we start with 100, the question was asking how long does it decay to 73% of its original size? So if the original size is 100 grams, what's 73% of that? That's just 73 grams. That's why I picked 100 grams. This is a nice number to get the percentage. Okay, so the question is essentially asking how long does it take to decay from 100 grams to 73 grams? Okay, so let's get our table again. So after 0 years, so no time has passed, you have your initial 100 grams, the entirety of it, okay? After 7370 years, it halves, so we have 50. And when you don't really need to do all this, but I'm just showing a few cases. So if we want to go another 7370 years, I didn't even do the math. As you can see, we don't really care for this problem. 7370 times 2, so another halving occurs, so we have 25 left. So what's our model? It's like 100 times half to the 0, 100 times half to the first power, 100 times half to the second power, so on and so forth, okay? So notice that our guy, the amount of time it takes is going to be between 0 and 7370 years. We're not at 50, we're at 73 grams, so it's less than 7370 years, okay? So we should expect our answer to be in between this, first of all, okay? So let's set up the equation now, okay? So we want 73 grams, okay? The final value. So even if we don't memorize the formula, we can kind of get it from here because this is 100 equals 100 times half to the 0. 50 equals 100 times half to the first power. This is where I'm getting all this. Okay, so we essentially want 73 in this column. So we use our model now as 100 times half to the t over 7370. This is actually the exact formula. But how do we understand this t over 7370? It's again, how many halvings occurred. So if after 7370 years, one halving occurs. So it's 7370 divided by 7370. Okay, after twice of this amount, it's that amount. It's 14,740 if I did it in my head correctly, over 7,370, which is 2. Okay, so that's why we set it up as t over 7370. This is the amount of halvings that occur. Okay, this is the first hurdle to set this up if we don't remember the formula or don't have it memorized. Okay, so I'm again hopefully really showing that we don't have to memorize it. It could help to memorize it. I'm not saying to not memorize it. If you want to, by all means, but we don't have to memorize it. And I actually don't recommend memorizing. If we are able to think this through like this, we're okay. All right, here's the other struggle now. Solving for t. We need to be good with our logs and all that, okay? So we need to isolate t. So right now, t is in the exponent. We somehow got to bring this down. So let's isolate this exponential first. So we divide both sides by 100, okay? So that's this line over here. Now, how do we bring this guy down? Well, you can think of it in 2 ways. I think now they teach it as convert this exponential equation to a logarithmic equation. So that's from this line to this line, okay? Or you can just think of, I'm taking log base half on both sides, and then you get the same thing. I'd prefer the latter, actually. That's how most people think about it, to be honest. Okay, so from here, we just multiply by 7370 on both sides. So that's right here. So nowadays, if you have a fancy calculator per se, you can do log of any base. But if you have a older calculator, you might not have that nice button. So we need to use the change of base because calculators, at least back in the day, only provided log base 10 and the natural log. So we have to change the base of the log in order to use those buttons. And actually, in computers nowadays, if you're ever a programmer or whatever, they won't have that nice button on those calculators of log of any base. At least to my knowledge. I program for my career. I'm not a programmer, but I use programming in my career. And they only have maybe log base 2, they have, but they for sure have log base 10 and natural log. they don't have like log base 3, log base 4, and all that. And it's just too much memory to store, to be honest. So that's why we need to know the change of base, because even computers nowadays don't always have the programming languages and libraries in those languages don't have log of any base. We got to know to change the base. Okay, so we changed the base, that's right here. And now from here, I chose ln, by the way. You can do log base 10. Totally fine as well, doesn't matter. And if we put this in a calculator, we have 3,346.213. The units are years. And we expected it to be between 0 and 7370, which it is. Okay, so let me go back here. So here's one way to think of the algebra, or solve the algebra. Here's a different way. Okay, if you're not comfortable log base half. Okay, I can rewrite this half as 2 to the negative 1 power. Okay, and then as a result, by properties of exponents, I could write as 2 to the negative t over 7370. And then the steps afterward are similar. You can pause the video to check it out. But you still have to change the base, but instead of log base half, you might get intimidated by a fraction as the base. So just do this, log base 2, not as intimidating, hopefully. But the steps are the same, are very similar, okay? And we notice that actually ln of half is, well, log base half is ln of 1 minus ln of 2, which is negative ln 2, because ln 1 is 0. So that's why if we have it like this, it's the exact same, because the only difference was this minus sign, and this is half. And by this, that explains why here it's minus and positive, but ln 2. Okay, this is getting technical now, but if you're interested and want to be flexible in solving these to be more of a quote-unquote advanced student who truly understands the algebra and all that, this is a different approach. Okay, now let's use the formula. So this is the general formula. So we still have the issue that y and y0 are not given. So we can use the same technique as before. We just choose, for example, 100 milligrams as y0, and therefore y is 73% of that, which is 73. So exact same formula as before, right? So we can follow the exact same algebra to solve for t. Or alternatively, we can just do it symbolically, because doesn't matter what our initial value is, our final value is 73% of the initial value. So let's translate that into an expression or equation. So that's what I said over here. Y is 73% of y0. So we translate that to, as an equation, y equals 0.73 y0. So we plug this definition of y into over here, our formula. So we get 0.73 y0 equals y0 half to t over 7370. And notice this is actually the exact same thing as this up here. Here, if we divide both sides by 100, it's 0.73 on the left-hand side, right? And then it's just half the exponential on this side, half to that guy, okay? Here, notice if we divide by y0 on both sides, it's 0.73 equals half to that guy. So exact same thing. So we don't have to pick an arbitrary initial amount. It could help, or we can just think of it symbolically like this. There's another way to think about it. Okay. Those are my two problems. Now here's the relating the calculus stuff into this general formula, if you're interested in that. Okay. So in calculus, you learn that the general exponential model is y is y0 e to the kt. So again, y is the final amount, y0 is the initial, t is the amount of time that passed, k is what we call the growth or decay constant, okay? So for the specific case of half-life, this k is a decay constant, so it's minus ln 2 over h, in which h is the half-life. Okay, so how do we derive that? Well, we start with the general formula. So half-life, so we want half of y0, so our final value is half of y0 right there, and the amount of time that passed is the half-life, h. Let's call it, okay? So we solve for k, so we divide by y0 on both sides, we natural log both sides, divide by h. So we get ln half over h, which, like I did in the slide, by properties of logs, this is ln1 minus ln2. ln1 is just 0, so it's minus ln2 over h. So that's how we derive it. Okay, you might learn this in calculus to derive this. Okay, so somehow, some way, this formula with our k that we just found is equal to this formula over here. Somehow, some way, they look very different, but they're actually not. We just use properties of exponents and logs. Let me get rid of this period to avoid some confusion, okay? Let's go through this. E to the minus ln 2 over h times t. We can rewrite this as e to the negative ln 2 power all to the t over h power. Properties of exponents, okay? Now, we can, inside this exponent, we can use properties of log. We can bring this -1 out back into the log. So 2 to the -1 power. Okay, e to the ln of 2 to the -1 power. The e and ln are inverses, so we just keep the arguments. They kind of cancel. So we have 2 to the -1 power to the t over h power. But 2 to the -1, that is just half. So you can see how these are equivalent, and they better be. Okay, so this, if you are interested and will take calculus, or this is probably flying or going in one year and out the other, which is fine for now. But if you're a calculus student or you're watching this for some other reason and you're just interested in what this video was about, this is relating calculus to this formula that people often learn in their pre-calc or algebra 2 or whatever class, math 3 nowadays too. Yeah. All right, that's it for this video. Hopefully this was helpful in explaining how to think through the problems without memorizing the formula, or just how to use that formula and the algebra that can be difficult to solve for time. All right, please give this video a like if you found this helpful in any way. It greatly supports the channel.